What we're going to do is we're going to have you help different people each time. Help me tell what's what. I'm going to start on the back row, go across, and then come up and go across. Okay, so hopefully you'll got it done. If not, you can ask for help. So let's start over here. A. Tell me what I need to do. Good. And what type? Good. I did, there we go. Okay. B. Okay. Good. Okay, C.
Put a 3 in front of the H2 and then 2 in front of the L and H3. And then get
Okay, good. Okay, D. Good. Okay, E. Okay, and what type is it? It's what? Animals do when they die?
Decomposition.
Decomposition. Because it's one thing going to two, even though the two are the same. Okay, F. 2, 2, 3. Good. Okay. Good. Okay, front row, you're not getting out of it. We'll get you later. Okay? All right, so we've got these. We're going to refer to these balanced equations through the rest of the whole worksheet. I'm going to do 2 with you. The rest is going to be yours to do on your own. We'll talk about the rest, but I'm only going to do 2 with you. You had examples before we went on Christmas break that you can go back and look at. We also had notes you can go back and look at, okay? So I will help you. I'll wander around the school, or around the class. Yeah, I'll wander around the school and go la, la, la. Oh, it's hard coming back from winter break, isn't it? Okay, so this first one here, how many moles? This, by the way, right here, tells you what equation to go back up and look at. Okay, so we're going to go back up and look at A here in just a minute. But we want to know how many moles of water, remember my little trick here to keep track of what we're doing, per mole of oxygen. When it says per mole of oxygen, what does that mean? How many moles of oxygen do we have? 1. Good. So we're going to do 1 mole of O2. That's where we start. So whatever number we're given or whatever amount we're given, we always start with this. So everybody write this down with me. We're going to go back up and we're going from oxygen to water. So we're going back up to A. I'm going to do it so we can see here. So we're going from here to here. Since we're at oxygen, we want to get rid of oxygen. We're going to put the number that's in front of oxygen down here. So it's 1 mole of O2 on the bottom. And we want to go to water, so it goes on top. So we go 2 moles of H2 on O on top. That way, we can then cross out mole of O2, mole of O2, times through, and we get 2 moles of H2O. Circle or square your answer. That's it. Okay, so I'm going to skip down. Let's go down to number 5. I told you I'm going to do 2, so I'm going to blank out the rest. I'm going to do number 5 with you because I put the wrong number here, wrong letter. This letter right here should be B. Should be B. Okay, so reading through it, how many grams of aluminum oxide can be formed from 1.5 moles of aluminum bromide? So starting with what we have, okay, which is 1.5 moles of aluminum bromide. Since we're in moles, we can go right up to the balanced equation. If I wasn't in moles, if I started in liters, or if I started in grams, I have to go to moles. That's where we use our mole map. From a mole map, to get to moles from liters, we'd have to divide it by 22.4 liters. To get to moles from mass, I need to look up on the periodic table and add up the mass, and then divide it by the mass. So here we're already there. So I don't have the balanced equation in front of me. So tell me what is in front of the balanced equation in B for AlBr3. What's in front of AlBr3? 4. So we put 4 moles of AlBr3 on the bottom because we want to get rid of it. We want to go to aluminum oxide, which is the Al2O3. What is in front of Al2O3? 2. Okay, so at this point, we can cross out moles of AlBr3. But we're still not to grams. So our next conversion here needs to go from moles to grams. I want to get rid of the mole. It goes on the bottom. Whenever I'm going from moles to grams, it's always just 1 mole. To get to the grams of that, I'm going to have to put in my calculator. I have 2 aluminums at 26.982, and I have 3 oxygens at 15.999. I don't have to write this down. I can just put it in my calculator, but I'm just showing you how to do it. Okay, I add those together. What do we get? If you haven't got a calculator, I've got a whole bunch over there. You're going to need it. Go grab one. 101, give me 5 sig figs. 96. So when we add stuff up, we always want to add it up to 5. So here we get 101.96 grams of Al2O3. We're going to cancel out moles. We're going to times through the top. We're going to divide by 4. And we have 2 significant figures, so let's give us 2 significant figures. So finish writing it down. I have a 76 grams of Al2O3. Everybody okay with that? Everybody get that? Circle or square your answer. Okay, we're going to look at the back side just for a minute because we had some questions last period, our first period, and I want to make sure we went through those questions. So looking at the back side, you've got some that go from liters. Remember that 22.4 liters is equal to 1 mole at STP. So you can use that as a conversion. You don't have to add anything up. It's just 22.4 liters equals 1 mole. And you can put it on top or bottom if you want to get rid of it or go to it. That's on the bottom part of your mole map. Now, once you get to number 12, on number 12 you're given 2 numbers, 6 and 4. You actually have to do 2 conversions. One with 6 moles of nitrogen going to ammonia, and ammonia is NH3, and one with 4 moles of hydrogen going to ammonia. Whichever one's the smallest then becomes your answer. Remember when we did the teddy bear s'mores, the mini s'mores, and you had to figure out how many s'mores you could make? This is the one that's the limiting factor. We don't know which one we're going to have excess of, so we got to figure out which one will make the least. So once we figure out which one makes the least, that's the one we circle. When we get on to 13, okay, on number 13, we now start with grams. So now we got to change each of these from grams to moles, then from moles to moles, and then from moles of bromine to grams of bromine. So you're going to have 3 conversions. Okay, again, you'll pick the smallest one. That'll be your answer. So instead of counting up, we would be weighing them. Okay, now the next one, number 14, you start with this much and you got this much, but you don't know how much you could have made. So maybe I could have made 75. Okay, I don't know. So I have to start with the 50 grams, and I have to convert it through to grams of FeCl3 to see how much I could have made. Okay, once I do that, it's asking me for the percent yield. Remember that your percent yield is just like finding your percent on a test. You got 40 on the test, but you got to figure out how many was possible on the test to be able to find your percent. So once you find out how much is possible, you're just going to take your 40, divide it by your possible, times it by 100, and you got your percent. Okay? Down here at the very bottom, this one we have 2 that we started with that we've weighed out. We don't know which one's going to be what we're going to run out of first, so we're going to have to take these 2 through. Now, this one did not give you a lot of room down here at the bottom. So I would be really skinny on number 14 because you only have to do 1 conversion across. So you maybe could put 25 AL and do it above here, and 2.5 AL203 and do it on the bottom. You're going to do the same thing. Whichever one makes the least, that's what your total is going to be. And then it says I made 2.5. So I'll have 2.5 divided by a small number, times it by 100, that's my percent. Okay, you should always end up with what as far as a percent yield? Greater than or less than 100? Less than 100, good. Okay, so we're going to be working on this the rest of the time. You get stuck, call me in, I'll help you. A lot of the kids, first period, were able to finish. Okay, so let's get it done. If you don't get it done in class, it becomes homework. So let's do it.